Program. The Program is a show that teaches you how to program, assuming you know nothing about how to program. And you've also found the very first episode. So let me explain a little bit about the program. So with the program is going to weekly take a particular language, and it's going to teach you a little bit more about that language. And we're going to do it in 12-week segments, 12 weeks for each language. And this is our very first show. And these first 3 shows that we're going to do are actually going to give you some background on the computer itself, not necessarily a particular language, because there's some things that are very common across all languages. Computers work the same way. They store memory the same way. And what we're going to do in these first 3 weeks is talk about variables, memory locations, conditional loops, things that every language has to have because every computer has it. And we're going to describe a little bit about some different languages in the process and how they handle variables and things, but we're not going to go into any great detail about the language itself. And then after these 3 weeks of the basics, we're going to start on Python, which is our first 12 weeks of learning the language. And we haven't picked what we're going to do for the second one yet. But you're probably going to see me for these first three weeks, and then through the Python, and then somebody else will teach the next language. I'm trying to find people who know the languages much better than I do, and they can teach the languages instead of me. So I'm still around, but I won't be in front of the camera the whole time. So this week, like I said, we're going to start out with the very basics, and I mean the very basics. We're going to start talking about like what a CPU is and very basic stuff. But the thing about learning the basics is, and I have this theory that if you can learn one language, you can pretty much learn any language, because under the covers, if you understand how things are working under the covers, you know what's going on, and you can translate that into the new language. And typically when you go from one language to another, the biggest change is the semantics, like where certain semicolon belongs at the end of a line in certain languages. Our languages don't require that. If you're doing a conditional statement, sometimes they're going to be in brackets, sometimes they don't. Sometimes they have an ending word. So there's all these different things, but in the behind the scenes, they are functioning exactly the same way. No matter if the if statement is in brackets and parens, or if it's a conditional block, it's all conditional. So if you understand what's going on in the background. Same thing with variables. Variables are handled very differently across different languages, but under the covers are doing the same thing. So if you understand what's going on under the covers, you can pretty much go from language to language and learn a language really quickly. It just ends up being the structure of the language and the semantics, like where certain things are. So that's what we want to teach you, the basics now, and trying to get you into that. So a couple things before we get started, a few housekeeping things. You are watching this on the TechZen TV network. And you can go to youtube.com/TechZenTV and see all of our shows. We've got lots more shows other than this one. If you found this one, this is the first one you found, we welcome you, but there are plenty more you can go and watch. We also have a Twitter account, and it's twitter.com/TechZenTV or @TechZenTV if you're in the Twitter sphere. So we welcome all kinds of comments, and you can always send email to the program at TechZenTV with questions, suggestions. If you see us mess up somewhere and you want to make sure that we acknowledge it, that's fine too. We definitely like to put that on here. Plus, if we said something wrong that can confuse somebody, we definitely would like to know about that. Okay, so let's get started on the basics of a computer. First of all, a computer has a few essential parts. A CPU that does the thinking or does the calculation. I'm not going to call it thinking, and I'll explain that in a second. It does the calculations. It basically follows a set of instructions to do calculations. And then you have an area for memory, or some people call it RAM, or for all kinds of different names for it, but typically it's RAM or memory. And that is where the computer stores temporary information. And then you have longer term storage, like a hard drive, that stores more permanent information. So if the machine turns off, you don't lose that information. So that's the basics. So the reason I said about you don't want to call it thinking is because the computer really cannot think. It follows instructions. It follows the instructions that the humans give it. It can't say, it can't answer a question that's just generic. Let's see if I can give you an example. If you ask it a question like, what color is the sky? It can't think to figure that out. You have to give it the instructions to be able to take the color of the sky and do the mathematical calculations to figure out what color it is. And so it doesn't think. It's not like you and I, we just think about, let's go do this. It just doesn't do things on its own. It doesn't predict anything. It doesn't dream of anything. It doesn't really think. It follows the instructions that are provided to it. So that's something that's very important to remember. You know, so I've heard some people say, "Oh, it's the computer's fault." Well, no, the computer's doing what it's told it to do. It could have been a human who told it to do the wrong thing, but it's not the computer's fault. It's following instructions. So something very important to remember. Okay, so we mentioned what a CPU was. Let's get past this stuff. So what I want to go into is how the computer stores everything. So everything in a computer is ones and zeros. And I know you've heard this before. Everything's ones and zeros. But if that's the case, how can you get the letters A through Z, or, you know, numbers 2 through 9 if it's just ones and zeros, and all these special characters? And we're going to talk about that, and I'm going to explain a little bit about how memory works as well in this process. So we're going to be referring to, especially certain languages, a byte or a word or a bit. So if you've seen any of the other text and TV shows, one of them is Let's Make It, and we do programming all the time. We do things at bit level in the Arduino. So you may have understood this a little bit, but what I want to do is I want to jump over to my computer screen, and I'm going to explain a byte and a word in the bit. So let's go over to my computer screen. Okay, the very top here is, see the bit, the purple? It's basically one of the ones and zeros. So you see this is all ones and zeros across this right here, all ones and zeros. And the 1 is a bit. It's considered a bit. And a byte equals 8 bits. So this whole thing here is a byte, and I want you to think of this as a character. It could be any character, A, B, C, or whatever, but these 8 bits that make up the byte can be any value. And I'm going to explain this in a little bit coming up here in the next section. So beneath that, you see a word is 16 bits, or it is 2 bytes. 2 of these equal a word. And that's very important to remember when we come up talking about the different variable types coming up here in the next. So how do you get a value out of a bunch of ones and zeros? Well, here's how it happens. It's considered a 2's complement type of value. So the very first number, in this case, we're considering it's considered least significant bit, and it's to the right. So it's LSBR, and this lowest bit is worth 1 right here. This bit is worth 2. This bit is worth 4. This bit is worth 8. This bit is worth 16. This bit is worth 32. This bit is worth 64. And this bit is worth 128. So each of these different positions has a value. And the way we get the value is, if it's a 1, then we add that position's value up. So in this case, we're going to add a 1, a 4, an 8, and a 16, and a 128. So I'm not that quick in my head at doing this, but so right here would be 5 plus 8 would be 13, plus 16 is 39, plus 128 is, can't do that in my head, 167. So this would equal to 167. All right, so it's equal to 167. That's still not an A, B, C, D, or whatever. So here is there's a table called an Ascii table, and I don't have this in my notes here, but it's Ascii, and you can just go, actually, let me just bring it up here. I can probably find it faster. I can just type in Ascii chart, right there it is, and here's a whole bunch of them. So let's go bring up this one, and here is the decimal value, which is what we're looking at. So let's say I wanted a capital A. So here's a capital A. And if we go over here to the left, we see its decimal value is 65. So what I would do in this case, if I was storing this A in memory, it would be whatever value equals up to be 65, which would in this case would be 1 0 0 0 0 1 0. So that would basically be this bit right here would be 64 plus 1 would be this one. So it would be just the very first one and next to the last one. So that's how you get 65, and that translates to an A in the Ascii table. So in the computer and in memory, you're storing information like this. There's a a big area of a bunch of ones and zeros, and it's typically done in megabytes. So a byte is 8 bits, and say you got 1 megabyte of memory, that would mean you would have 8 megabits. You have 8 megabytes of memory, you'd have 8 megabits, so 8 million bits. So you can see how it adds up really fast. So there's a little chip that has all these ones and zeros that can be addressed. So let's talk a little bit about addressing now. So in the program, let me scroll down here. I think I got another demo, another thing of this. So you have in memory, and in more modern computers, it's a little differently than in the older computers where there was just one big physical memory. Now they actually have, because it's considered virtual memory. So your program resides in this virtual memory, and your program data rides in another area of virtual memory. So what virtual memory is since we have so much memory these days, I mean, there's tons and tons of memory, it doesn't make sense to make this all one big memory area. And there's also security reasons, which we'll talk about in other programs. But basically, your program is given so many bytes of memory. You request this when you define the variables in your program loads. So you give this space right here for your variables, and the computer will say, okay, well, you need this much space. It's going to look to you like it's right here. But when you ask for it, we're going to go the whole way over to this area because this area is open right now. So in the area, this advantage to this is if your program, and this makes it hard for malware as well because your program is the only one that knows where this is located. So if another program is running and it wants to get to your data, the system, it has to interact with it. And the system will tell it, no, you can't have that information. It doesn't belong to your program. So it's just another way of protecting it. It's considered virtual memory. But if we look at it from the memory point of view, just in general memory, there is basically ones and zeros starting at this first position, going the whole way down to the bottom, to the physical memory bottom. Ones and zeros, tons and tons of them. So it's this really large area of memory. And your program variables basically point to a particular memory area. And we're going to talk about variables coming up next. But and each variable is a different size as well. So in this memory area, you have different sizes of bytes in words. So give you an example, an integer, which is a word-sized value. So they will take 16 bits to store a number. So if you want to store an integer, which means no periods, there's nothing. It's like a full number. It would be stored by default. You can do small integers, which will only store up to 256, but you can store up to 16 bits, which is the default, which is a maximum value of 65,542 or something like that. We'll get to that here in a little bit. So you can see the maximum value if you would take and follow this same pattern. So the next bit would be 256, and then it'd be 512, 1024, 2048, 4096, and down the line for each one. And you made these all ones and you add it all together, that would be the maximum value. And the maximum value is, we'll get to the variables here, is like 65,000 something for a standard integer. Now, they do have different variations of integers, especially depending on the language. One's called a small int, and it actually is only 1 byte. So its maximum value is 256 or 255. And you can get a long int, which is 2 words, which is, I can't remember the exact value, but it's pretty far up there. It's in the billions. So I don't know if I can have that in this document that I have created here. So anyways, that's how we store information in memory. It's all in ones and zeros. And I'm sure you've always heard everything's done in ones and zeros. And it truly is done in ones and zeros inside the computer. It's stored like that. And then it's translated to human speak much easier now. Back in the old days when computers were first being used, everything was done in this or hex or so it was always converted. In fact, if you go look through assembler, and I don't know if we're going to teach assembler on here yet. We haven't talked about going to that level of detail. You'll be able to see how it's done in assembler because there's some very specific ways it's done still under the covers, just like it was back in the old days. It's just now we have layers and layers of stuff on top of it that kind of hides us from this. All right, so let's go down and talk about variables and data types. So basically, let's think what a variable is. A variable is exactly what the name is. It is a place that information can be stored, that it can be varied. So this is one part that I've heard some people that get stuck with a variable. They think that when they put something in a variable, they're putting it in something physical, and it's nothing physical at all. Basically, what a variable does, and I showed you this image here a little bit ago, is it points to a location in memory. So when you define this min value, so this is a C program, and it's defining an integer with the name of min, and it's equal to 10. Well, what min does when you say it's equal to 10, and if it hasn't been defined, it will find memory, free memory. And in this case, it's integer, so it's going to be a word or 16 bits. It's going to find that memory, and it's going to reserve it. And the C in the application is going to, the operating system is going to say, okay, you wanted 16 bits reserved. Here is your address. And that comes back, and inside this language, whatever's running the language, it's storing this value somewhere, and it probably is storing it in another memory location. So if you typically look at assembler, you have this area of memory that says, here is the name, and here is the memory location. So when you go look at min, what happens beyond the covers, it goes, okay, where's min? It goes through the memory and finds where min is. And then it says, okay, here's the address. And then that address goes and looks at this memory location. So it's another memory location that stores a memory location. It's a known memory location of addresses that you can go find out where the other memory location is located. It's all kind of done under the covers though. So to you, it looks like I'm setting this variable equal to min, and min's really pointing to somewhere in memory, and it's storing the value of 10 in that 16-bit memory space. And then we do something with max. It's going to go say, okay, I want to define max. It's going to go get 16 bits of data, set that in the background saying max's location is this. And we're going to put whatever bits that equal 50 out in that memory location. So that's basically what a variable is. Now there's different kinds of variables. We've been talking about the integers because they're probably the simplest to understand. But we're going to start talking about the other ones here. So I mentioned when we first started about the letter A, for example. The letter A by itself, just one of them, is considered a character. And a main language is called a char. And it's basically a single character. It can be, here it says like an X or a special character or a star, 4, or whatever. It's just one single character. And it does have a numerical value. I don't know if we're going into detail on this because it's different for every language, but there is a numerical value because it's stored a value, say 4. If we go over here and look at our chart, a 4 is a decimal value of 52. So if we assume that this 4 is equal to 52, we put in the binary memory 52. If we would pull that word out and say, what is its value added up by all the ones, it's going to be 52. So, but basically, it's a single character. A character is a single character, exactly like it says. So a string, and this is going to get a little confusing because we're going to talk about something that's a string in some languages a little bit later here. A string is a string of characters, a bunch of characters put together. So what would happen is if you had a string of, say, 10 numbers you wanted to put into memory, it would reserve 160 bits, basically 2 words times 10, 2 words, 16 bits, 16 times 10, 160 bits. And it would restore that space, and then it would basically keep putting that string, each value in that string, into memory location. So the first word would be the first one, the second word would be the second letter, the third word would be the third letter, down the line, just like that to fill everything up. Now, the reason I say this is confusing is we're going to talk about arrays, and in some languages they consider a string a character array. So it's like a single character in an array, which technically they're the kind of the same thing, because if you look at a string, it is an array of characters, but some languages handle a string natively without doing anything special. Some of them require you to do a character string. But just think of it like this, so it doesn't get confusing, is no matter if it's a string or an array, it's still an array of characters. No matter whatever the language calls it, doesn't matter. Okay, so let's go on down here, and we're going to talk about an integer. This is something we've already talked about since the beginning here, and it's int. In some languages, integer is its real name, and it's a whole number, meaning there's no decimal points, no decimal points with anything after it. So if you would take 65.78, that would actually, in most languages, round up to 66 evenly, but it's definitely not an integer. Some languages will cut it off at 65, but most languages will round that up automatically at 66 based on the standard rounding rules. And then we had the floating point numbers. So this is a number that can have digits after the decimal place, and it's a little, I don't remember the exact size, the default size for a floating point, but I think it's 2 words. And I have to go check that out to make sure. So it would be 32 bits for a floating point. And it can be an integer value. It can be 65.00, for example, but it would take 65 dot whatever. So it does say it takes more memory, and it does. I think it's twice the amount of a basic integer. And then we have Boolean, which it basically is either a 0 or a 1 or true or false, depending on the language. And it is the simplest data type there is, but it still takes an entire byte of memory. So you can't get away from using an entire byte because everything's done in a word format in memory space. All right, so here we get down to array. And this is where I said before, this can get confusing because technically a string is an array of characters. And depending on the language, that's how sometimes they represent it as a string, sometimes they represent it as a string of characters. But basically, in addition to a string of characters, an array can contain, and this is again dependent on the language, it can contain an array of variables. So let's say you have a language that supports the string, and you have 100 strings, and you want to put them into an array. And you can do that real easy. And you can still do, even if it's an array of characters, you can still do a double size array, which would be an array, basically an XY array, and still do the same thing. But you can put other things, depending on the language, again, different things in an array. You can put memory locations, you can put function locations, which we'll talk about functions later. I think it's even next week. And functions in an array allow you to basically call a function by a number that can come in as a command. And that's really helpful if you do state machines. We'll talk about state machines at some point as well, in some of these as well, these shows. I just don't know exactly which ones yet. So an array basically is simply or essentially a list of other variables. And it can be a character array or a string. It could be an array of integers or array of floats. It could be an array of booleans. It doesn't necessarily matter. Okay, so there are other variable types, but these are the most commonly used, and the other ones are typically all variations of these. So we're going to stick to these very basic ones. And the main thing I want to get through here was everything is stored in memory as ones and zeros, and it's typically stored in the word or a byte format and has an address attached to it. Okay, so the next thing, and this is going to be probably a tad bit confusing, and it's considered a strong or a weak type. And what that is some languages hide you from a lot of things. And I showed you an example of C where you have to define this is an integer, or this is a long int, or this is a char. You have to define everything that you use in a variable. There are other languages that don't care what it is. They basically handle it all for you behind the scenes. And that can really complicate some people's thinking, because you say this variable is equal to A here, and at some other point you say the variable is equal to 5. Well, the language will try to figure out, is that 5 an integer or is it a string? So there's some things you got to do. And typically you put the 5 in quotes and they'll know it's a string versus a value. But there is no definition. You basically define a variable name and say what it's equal to, and it's considered weak typed. So it's flexible, I guess is probably the best way. I wouldn't call it weak. It's flexible. And PHP is a great example of this. You define variable name equals, and you can make it a number or you can make it a string, and it will do everything for you kind of behind the scenes. The problem with this becomes, like, if you're in C and you have two integers and you add them together, obviously the result's going to be an integer. It's going to be a number. However, if you have in PHP, for example, a string and a number, you try to add them together, what's it going to do? Because you have, library is the word and trying to add 5 to it. Well, one's a number and one's not. So what's the computer going to do? And it can give you some interesting results. So that's the difference between a weak typed and a strong typed. So if you're strong typed, you're forced. You know what the variable is. And I would say that probably more than half of the languages are strong typed. Most of the very big languages that do all the big applications you can download from the internet, install on your computer, are typically strong typed. Where you get into things that are considered weak typed are more user side, like JavaScript or PHP type environments, where they're not compiled languages. They're more interpreted. And they're compiled and interpret things coming up a little bit later. We're not going to talk about that right now. So basically, we we have the two different types of languages. And the first language we're going to teach you is kind of, I don't want to say it's in the middle, but it's more towards the strong types, and that's Python. But there are some exceptions to that too, and we'll go through that. And each language is different. We're going to spend time in the beginning of each language talking about defining variables, and we'll make sure that we say is it strong or a weak typed, and explain that yet again. All right, so now we want to look at how you assign a value to a variable. And we kind of already showed you this in the one section where we were defining an int and an equal. So that's basically all you really have to do to decide to add a value to a variable. And it pretty much works the same in every language. Now, some languages require you to do additional things. In the case of some of the more I don't want to say they're not compiled, but the more interpreted languages, you have like maybe a word set in front of it, or a variable meant to have a $sign in front of it to say that it's a variable. Other languages do not require that you have a $sign in front of it to show that it's a variable. So again, this is the semantics of each language. They ultimately run the same thing. They're assigning this value into this memory location, but they don't have to be named. They can tell what it is. So one language makes you put a $sign in front of it. That typically means that it's a variable. And other languages make you define it ahead of time, and you don't have to put a $sign in front of it. And other languages don't have to define it at all, and you just put a name there. So example, JavaScript, you just give it a name, equals, and a value, and it'll assume that if it's an equal sign, you want to assign that value to memory. However, other languages don't know that it's a variable if you don't put a $sign there, so it doesn't know what to do with it. And they may use the equal sign in some other way. They're not using the equal sign as the trigger saying they're trying to set something, a value here. They use a $sign saying it's a variable, so it knows what to do with it. Again, it's something different between each language, and we'll go through that in each individual detail. But in general, you typically do the variable name equals and then the value. And if it's a certain language that requires a $sign, it'd be $A, for example, equals 5. Or if it's one that requires set, it would be set A equals 5, things like that. So a little semantics, but in behind the scenes, it's still doing exactly the same thing. So I mentioned about the set and the $sign. I want to make sure I covered that. I saw it in my notes right there. And I think that's pretty much all we want to cover in this first week to get you kind of found. Oh no, here's something else I want to talk about. So there are some languages that it's considered an equality versus an assignment. So and this is more likely the case in most languages, where a double equal sign is not an equal, but is a comparison statement. So let's say, and we're going to talk about conditional statements next week, but let's say you're doing a comparison statement. You want to see if, instead of setting A equal to 5, you want to see if A is 5. So it would be A equal 5. And that's something that's a little bit different. In fact, if you have a conditional statement that says if A equals 5, then do this, it's always going to be true because you are setting A equal to 5 because it's not equal. Something we'll do in conditional statements, but I just wanted to bring it up since I was talking about the equal sign. All right, so let's see. Did I cover everything I wanted to cover this week? I think I did. I don't want to spend too much and overwhelm anybody. And I'm sorry if you already know enough about this stuff that I'm boring you, but we want to make sure that it covers everybody that wants to learn the program from not knowing anything. And if you have questions and you will maybe like us to come back and re-clarify some of the stuff, please let us know, and we will definitely do that. So what we've done for the first 3 weeks is kind of picked out some certain subjects, and we're going to go through each of them just to kind of get the basics of computers and programming. So next week we're going to cover conditional statements, loop statements, things like that, and go one more step the following week to talk about functions and classing and object-oriented programming, real high-level object-oriented programming, and the concept kind of behind it. So that's all I want to cover this week. I do want to remind you that if you want to subscribe, we would definitely love you to go to youtube.com/TechZenTV, hit the subscribe button there. And if you can come give us a comment, that's even better. That definitely helps us out. People just don't understand how helpful it is. First of all, it's helpful for us so we know we're doing the right thing, but it also helps us to get found on YouTube. Other people, when one person starts to speak, everybody kind of jumps in and starts creating a community, and we love that part of it. If you want to follow us on Twitter, we are TechZenTV on Twitter or at TechZenTV. My name is Mike Myers. You can always follow me. You can go to mikemyers.me, or you can go to Twitter, and my Twitter handle is NetNutMike, NetNutMike. Love to have you follow me there. If you are getting the show on iTunes, if you could go to iTunes and give us a rating, if you think we're doing good, 5 stars, definitely appreciated. And leave a comment there too. That helps us. Is like YouTube. It helps us get found. And there's so many things in iTunes that you just lost unless people get out there and help you to get found. And that's why we ask you to help us get found. I think that's it for this week. This show comes out every Wednesday. We do pre-record these, and as other people are doing the future shows for the other languages, we put them in and release them. But you can email us anytime with any questions from any show, and we'd love to hear from you. All right, that is it for our first program show that we've had. We'll see you all next week. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.